We're going to get into solving absolute value equations, and as you recall, when you have an absolute value, whatever is inside of there, whether it's positive or negative, will come out to be positive. So inside of here, x could be, this x could be positive 8, this x could be negative 8. And those are the two values of x. So I would say that x could be positive 8 or x could be negative 8. Well, things change a little bit when we start doing stuff to the inside of that. So now my 4x could be positive 28 or my 4x could be negative 28. What that does is that sets me up with two separate equations. 4x could equal positive 28 and 4x could equal negative 28. So when I divide both sides by 4, I get x equals 7. Divide by 4, I get x equals negative 7. These first two examples can be kind of deceiving, though, because when you think about an absolute value up to this point, it's always been a number and its opposite. But when we get into problems like 3, and actually even the remaining problems as we go through here, when we separate that value, that x minus 6 could be positive 13, it could be negative 13. When I set up my two equations, because I'm going to be adding 6 on both sides, the values aren't going to be opposites of each other. So unlike 8 and negative 8 and 7 and negative 7, when we set up this, x minus 6 equals 13 and x minus 6 equals negative 13, I would add 6, x is 19, add 6, and x is negative 7. So I want you to understand that just because it's an absolute value doesn't always mean that the answers are going to be exact opposites of each other. I don't like the way that looks. I'm going to rewrite it so it's the negative 7. Okay? So when you set up your two equations for your each possible value that you have, you're going to follow regular equation solving rules. It's just that the absolute value sort of doubles our possible answers. So again, here I have 31 and negative 31, so I have two equations. 7 plus 3m, what's inside of there could be positive 31, and 7 plus 3m, what's inside of there could be negative 31. And now again I have to solve. So minus 7, I get 3m equals 31 minus 7 is 20, that's an m, 24. Divide by 3, so m is 8. I'm just solving like normal. The equation solving shouldn't be new to you. It's the breaking it down into the two equations that might be a little foreign. So minus 7, 3m equals negative 38. Divide by 3. That doesn't go in evenly, so I'm just going to leave it as negative 38 over 3. And that's fine to leave it that way. That's not a big deal. If you want to write it as a decimal or as a mixed number, that's fine. But usually, why make more work for yourself? Just leave it as that improper fraction. If it can be reduced, reduce it. Okay, so same concept going on the next. If you want to pause the video and give it a try and see how you do, that'd be fantastic. Otherwise, just follow along. Again, I'm going to take what's inside of here. 6n plus 7 could be positive 53. 6n plus 7 could be negative 53. I don't always have to draw the arrows up to there and break it apart like that. I just did at the beginning to sort of show what's going on. But minus 7, again, I have double the work. 53 minus 7 is 46. Divide by 6. And n is this one. I have to reduce. I can divide the top and the bottom both by 2. So I get 23 thirds. And then minus 7. 6n is negative 60. Divide by 6. N is negative 10. So my two solutions, 23 thirds and negative 10. Now the last two problems are going to be a little bit different because I'm going to have some work required prior to breaking it apart. The key to solving these absolute value equations is I need to have the absolute value alone on one side. And so on problem number 6, I have to remove that 1 first. So the absolute value of b plus 6 equals 3. Now I can break it down. b plus 6 is positive 3, or b plus 6 is negative 3. Again, a little bit more work involved. Get rid of everything around the absolute value, and then I can do my break apart. Minus 6 minus 6, so b is negative 3, minus 6 minus 6. On the other side, b is negative 9. So what should happen is, if I put these answers back in here, I should end up with the same thing. If I put negative 3 in here, I get negative 3 plus 6, which is 3. The absolute value of 3 is 3 plus 1 is 4. If I put negative 9 in there, I would get negative 9 plus 6 is negative 3. The absolute value of negative 3 is positive 3 plus 1 is 4 also. So both of these check to get the right answer. That's the goal. But they're not always, again, going to be opposites of each other. As we step up the activity on the outside, we have to do more work again. And again, when solving, you have to reverse the order of operations. So I'm going to add the 8 first. That's on the outside. I can't add those two things together because that 6 is being multiplied by that. And I can't distribute that through like we've done in some of the past ones because that is an absolute value inside of there. So it's going to change things up a little bit. So I'm going to add the 8. I get 6 times the absolute value of x plus 5 equals 30. And then I'll divide the 6 out. And so the absolute value of x plus 5 equals 5. And now I can break down my, I'm just going to move that down. I don't know why it does that. But now I'm just going to break that down into my two equations. So x plus 5 could be positive 5, or x plus 5 could be negative 5. That's inside of here. Again, that could be positive 5 or that could be negative 5 to result in 5 being, or the answer being positive 5. So minus 5, x is 0, minus 5, x is negative 10. So again, you're just going to have double the work when you work through these. Give it a try. If you have any questions, email me, and have a great day.